Hi, and welcome to today's program. There's a lot of information being discussed. I've learned a lot, and I hope you have as well. One of the things we try to do in the West Orange School District is to help young people develop the notion of recognizing patterns and numbers. And one of the things that's very effective in allowing us to do so in preparation for the NJASC exam is to look for those patterns in a variety of sets of numbers. For example, let's take a look at a common set of numbers that we're very familiar with, and that's the notion of perfect squares. You'll notice that we have columns of numbers that are written with exponents, where 2 in this case would represent the exponent, and this, of course, we know represents a number times itself. In this case, this would be 8 times 8, 5 times 5, 15 times 15, but you knew that already. But now let's write down the perfect squares as we know them, and then we can talk about them a little bit later. And you know your perfect squares, don't you? Sure you do. For example, 1 squared is 1, 2 times 2 is 4, very good. 3 squared, 9, everyone knows that. 4 squared is 16, 5 squared, 25, 6 squared we know is 36, 7 squared, right, 49, very good. 8 squared is 64, 9 squared is 81, and 10 times 10 we know is 100. Very good. 11 squared, excellent. 121, 12 squared is 144, 13 squared, right, 169, 14 squared is 196. 15 squared, you know, is 225. 16 squared, of course, is 256. 17 squared, right, 289. 18 squared, we know, is 324. And of course, 19 times 19, right, 361. Everyone knows 20 squared is 400. What about 30 squared? We know that's 900. But let's take it from the top. 21 squared is 441. 22 squared is 484. 23 times 23, right, it's 529. 24 squared, we know is 576. 25 times 25 is what? Exactly, 625. 26 squared is 676. 27 squared is 729. 28 squared is 784, and of course, we know that 29 times 29 is, right, 841. Very good. Now, our goal is to look at this array of numbers, perfect squares, and identify as many of the patterns in the numbers as possible. It's going to benefit our kids when we think about preparing for the NJASC exam. Patterns can be partial. It can involve 2 numbers. It can involve a whole column, a row diagonally, selective numbers, maybe a column within a column. You take a look. I'm going to give you a couple of minutes, and then we're going to see how many patterns in the numbers you can discover. Take a good look at it. Now, how many of the patterns did you discover? Well, first and foremost, if we're observant, you recognize that the last digit in every column, you notice that? They're the same. 1, 4, 9, 6, 5, 6, 9, 4, 1, and then a 0. You see that? Sure you do. Same here. 1, 4, 9, 6, 5, 6, 9, 4, 1, 0. The last digits for all of our perfect squares are the same. You'll also notice that our perfect squares, the 4 before and after our multiple of 5, right, those last digits are symmetric. What does that mean? Well, take a look. 6 and 6. You see that? Sure you do. 9 and 9. 4 and 4. 1 and 1. And we notice that for all of the columns. But those who have eyes we'll see. No doubt some of you recognize that not only is the last column symmetric, but if you notice our perfect squares for 20s and 30, the last two digits are symmetric. Notice our multiple of 5, right? 76, 76, 29, 29, 84, 84, 41, 41. Don't you love this stuff? Sure you do. And of course, you recognize that for our multiples of 5, the last two digits are always 25, no matter how far we go with our perfect squares. But let's do some careful investigating. These are some of the little subtle nuances that improve our scores. Look at 13 and 14 as perfect squares. 13 squared is 169. 14 squared is 196. If you know 13 squared, you know 14 squared because we're just reversing the last two digits. Take a look at 12 squared. 12 as a number 1, 2 squared is equal to 144. What happens when we take these two digits and we reverse them? We get 21. What's 21 squared? Well, it's the reverse of these three digits. 12 squared is 144. 21 squared is 441. Great stuff, isn't it? Here's another one. 19 squared. 1 plus 9 is 10. What does that tell us? Well, it tells us that the digits for 19 squared have to add up for 10 as well. 3 plus 6 plus 1 equals 10. Look at our multiples of 10. 1, 4, 9. Sounds familiar, doesn't it? Because it's our perfect squares. Now, watch this. Take a look at our odd numbers. Odd numbers. For example, 1, 3, 5, 7, 9, 11, 13. And the numbers go on and on. What happens if we add the cumulative sum of our odd numbers? 1 plus 3 is 4, perfect square. 4 plus 5 is 9, perfect square. 9 plus 7, right, 16, a perfect square. 16 plus 9, 25. This is great stuff. Let's take a look at the middle column of perfect squares. We talked about the last digit, but look at the first digits. It's as if the numbers and their totals are reversed. For example, 4 ones, 3 twos, 2 threes, and 1 4. You see that? Sure you do. It's trivial. But again, that's the power of our students having the ability to recognize patterns in numbers to make them better equipped to score higher on this NJ Asked exam. This is just one brief example, and you can share this with your kids. You guys can continue with your meeting. There's a lot of information to be discussed. As for me, I'm going to continue with some more perfect squares. I love this stuff. 31 squared, that's 961. 32 times 32, everybody knows that's 1024.